So I'm Shamir, and this is a notebook. If you notice, there's 3 cells here. X is 1, Y is 2, and X plus Y. Now, can you tell me what will happen if I run this last cell? No, it's 14. And that's because in Jupyter, if I run X, it's actually 12. And you can do this in Jupyter, right? You can create 10 cells of X, and each of them can mutate X, and maybe I can reorder the cells, and now my notebook state becomes very difficult to reproduce and to understand. I could even delete X at the top here, and this still works. X plus Y still works, which doesn't make sense, right? If you share this file to someone else, this shouldn't be able to run. The other thing to note about Jupyter notebooks is it's stored in JSON. Can you read that? Okay, let's zoom in. This is the source code of a Jupyter notebook. And if you try to version control this, because it stores the outputs together with the code, it gets really difficult to do a git diff or to apply Python best practices using rough or lint. So with all of that in mind, several years ago, Akshay, the founder of Marimo, thought, could we reimagine this experience? Could we develop it in such a way that it's suitable for developing modern Python applications? And I think so. I think we can. So I work for a company called Marimo. It's an open source reactive Python notebook. And throughout this session today, I'll hope to demo some of the features of Marimo and introduce you to a reactive notebook. So let's get started. Gonna delete everything. Okay. So it's a Python package, so you can do oh, it's really small. Okay. I'm just gonna use UV. You can use pip as well. It's already installed for me. So I'm gonna do Marimo, edit. I'm gonna pass a sandbox flag, and we'll see why later. And I'm gonna call my file demo.py. Also note that in the demo I showed you earlier, it was untitled 14, which is very common for those notebooks. Also to preface, they are great. Jupyter notebooks are great, and they have powered a lot of research and have done leaps and bounds for technology, right? And they also support different languages like Julia and R. So with that in mind, this is a Marimo notebook. This is the startup cell. And it's just a Python cell, so I can do things like print hello world. And if I run this, it will behave like normal. So let's try to recreate that experience, right? I did X is 1, run this, and then Y is 2, run X plus Y. So far, so good. And what happens if I do X is 10? Oh, it throws an error. So Marimo actually recognized that X has already been defined in your notebook, and you cannot do this. And there are ways to override this, maybe you can wrap it in a function, or you can make it a private variable. But that's an interesting behavior. So now let's say I do want to change it to 10, right? I go to this top cell, X, and I make it 10. Okay, I should zoom into everything, I guess. Okay. Notice it has a yellow border now. And I can click this run button. But pay attention to this last cell where it says 3. And what happens if I click run? It actually updated in place. So Marimo actually recognized that there's a link between the cells. That because the first cell defined X and the last cell referred to X, there's an edge that's created, and we have to update the last cell. And you can actually see this in the sidebar, right? There's this dependencies tab at the left. And if I open it, I go to graph. You can actually see a DAG that's been created. So under the hood, we just create a directed graph. And we go through each top down from the Python code. And we see, oh, the first cell defined X, second cell defined Y, third cell referred to both of them, so we create an edge. So if I go in here and do Z equals X plus Y, and then Z plus 5, what happens is the DAG expands, and if I modify something at the top, all the children cells will update as well. that also means that if let's close this out, delete this. If I go in here and I delete x, it throws another error because x is no longer defined anymore. So these are like really helpful things, and they are constraints on your experience, but if you accept it, I'm going to show you like all the use cases that can arise out of accepting this workflow. So you might tell me like, okay, it's cool, that's called reactivity, but what does it matter, right? How does it impact my work? I'm going to import some UI elements for now. I'm going to do this through import marimo's mo, and then go in here. I'm going to create a slider. Let's call it mo.ui.slider. It's going to get a start. I'm going to give it 3 and 10. And then a slider looks like this, so I can drag it around. Let's call it slider, and then I can display it. And then if I want the value of the slider, I can call slider.value. And now I get back the value, so I have a interactive like slider element. That's cool. I'm going to use this to draw some graphs, because that's very popular with notebook users. I'm going to import this package called PyMDE. PyMDE is just to compute vector embeddings. You'll see why later, but note that in this environment, I don't have PyMDE installed. So you might think like, okay, what's the Jupyter command to install? Like magic pip install? Well, this is a Marimo notebook. It's just a Python file. So if I do this, it actually detected that that package is not installed and will trigger an installation for you. So I have UV installed. That's why it chooses UV. But if you use pip or something else, you can do that. Let's install it. And it'll take some time. I'm going to import another notebook. This is just another file I have. And there's this function called drawGraph. So let's wait for that to load. While it's loading, maybe the internet is a bit slow. But I can do... Oh, it's done. Okay. I'm going to call this function drawGraph. It accepts like n number of items. So let's say 3 items. I have to give it an edges, which we have to do with PyMDE. And then it accepts an algorithm. Let's do quadratic for now. Let's create that edges variable. So to do this, I call PyMDE dot all edges. And then we do 3. I can run this, I run this, and now I have a graph. Okay. So maybe you can go in here and think, okay, this is pretty cool. What if I want to change the number of edges? Okay, I can go in here, I can change this to 4, and then, okay, now it breaks because I need to go in here and change this to 4. And then what if I want to like have this process to like see different number of edges, or like change the algorithm? Well, instead of manually writing the code, let's hook it up with the UI element, right? I'm going to delete this, and then instead of passing in 4, just pass in slider.value. Let's run this as well, slider.value. Run everything, and then now if I move the slider around, I actually create an interactive like UI element. So that's cool. Can I change the penalty algorithm too? So it accepts 3 arguments like linear, quadratic, or cubic. It would be nice to have a drop down, right? Okay, so let's create a drop down. There's something called mo.ui.dropdown. Can pass it a list of options. I'm going to pass in linear, quadratic, cubic. I'm going to also give it a default value of quadratic. And then I have to display it. So that's a drop down, pretty nice. Then the slider is gone, so okay, let's fix that. I want to put 2 elements together. I can put inside a VStack. So VStack is just a vertical stack of elements. I can put in a slider and a drop down. Okay, that's pretty nice. Let's add a label as well. So each UI element you can attach labels. So here, label, penalty, algorithm, let's run this. Okay, let's hook up, right? Let's hook it up. This penalty algorithm, I'm going to put the drop-down.value, and now everything should be hooked up. So maybe I can go around, I can change the number of edges, and I see, okay, quadratic doesn't really feel nice. Maybe linear. Okay, no, linear. It's all the same. Okay, let's change to cubic. Okay, maybe that's what I want. So, and maybe you want to present this to an end user or your stakeholder. You want to show the code, right? You can go to the right over here, toggle app view, and what that does is it hides all the code away, just shows the output, and you can have this like data application that you can share to your users. And a bunch of like the users that I see who do this, you can do something called marimo run, which is serve this as an app. Only this view, right? You can also hide like all the buttons over here and the Chrome. We call it a Chrome panel. You can hide all of those things. So let's look at what this file looks like, the source code. I'm gonna go to my editor. It's pretty small, I think. Okay, so this is the Python file that's been created. If you notice, there's two things. One is just Python. So each of these like function blocks are cells. They have a decorator on them, app.cell, that tells Marimo that this is a cell that you can display in the UI. And at the bottom, there's like a if name equals main, you can run this. So that's cool. Also at the top, these are inline dependencies. This is a function of Python, nothing to do with Marimo. In a recent PEP, you can actually declare your dependencies inline with the script. So I can share this script as a standalone like project with a friend, and they don't need a requirements.txt, they don't need a PyProject toml. It just follows the dependencies on this script, and they can run it by itself. And okay, so this is related to the sandbox flag I told you about. When I pass in sandbox, it does this automatically. Okay, so that also means I can run this as a script, right? Because it's just a Python file. So if I go in here and I detect there's a util, you can do like if ammo.appmeta dot mode equals to script. Oops. I can do something like print running from CLI, else print otherwise. So this function just detects whether this is running in script mode, which means it's running like Python demo.py, or whether it's running in a different mode. So there's also edit mode, because this currently is in edit mode because I'm editing the notebook. There's also app mode. But theoretically, if I do this, and I go back to my command line, and let's activate the environment again. And I do uv run python. You can also do python demo.py, but in my machine, I just use uv for everything. So if I run this as a script, it will install those packages. And now it is running from CLI. So I can actually customize my Python notebook to work in different ways when you're running from CLI versus an app. Okay, so that's all pretty cool. Let's see some like more complex notebooks. I'm gonna close this. Let's go to do this. I'm gonna do marimo edit. Let's close this. Okay, so if I do marimo edit, it just runs from the directory I'm in. And I have a bunch of notebooks here. Like all of these are Python files. I think all of them are marimo files too. So I have a notebook here to visualize charts. I think charts are pretty common for notebook users. So it's called embedding notebook. It has a bunch of cells. And I'll explain a little bit. Let me run all of them. Most not defined. Oh, okay. Okay. We're making out during runtime. Did I change anything? Okay, this might be, there's a breaking change with Altair, so I think that caused the issue. Oh, by the way, this is the packages side panel. If you want to see all the packages listed in your current environment, you can go in here and I can upgrade any package I want. Now I'm going to open the command palette, restart. Let's do this again. I think this should work. Okay, that doesn't matter. Poor internet probably. Okay, so this chart is based on an MNIST dataset. That dataset plots handwritten numbers, so like someone drew out 1, 2, 3, 4, 5, 6, 7, 8, 9, a bunch of them, and now I'm going to convert those to vector embeddings, like floating point numbers, put them on a chart, and see whether digits that look like each other cluster up. So in this chart over here, like the blue ones are digits that look like the number 0, or the green ones are digits that look like the number 4. So since it's a reactive notebook, right, maybe I want to inspect like these dirty values in the middle. They seem to be like in the middle of these digits. I want to know why. I want to inspect it. And if you do it manually, you might use like polars or pandas, go in and filter the data frame. But since it's a chart, I can actually make a selection, right? I can like use my mouse, make a selection of this, and at the bottom, I can call chart.value and then put it into a table. And then if I show you the whole thing, okay, I'll just change to app view for now because I don't have much screen space. So I can make a selection, and notice what happens if I like move the mouse around. Oh, sorry, what happened? Okay, let me zoom out a bit more. Okay, so as I move my mouse around, the table populates, and what I'm doing with that chart.value is I'm also converting it to an image. So this table over here, it shows like the floating point representation, so the vectors, and then like x, y, the coordinates, and the digits. But I want it to show the pictures, so I just converted it back to an image. And now I can use this mouse and like inspect my data. I can go and see, okay, this looks like 6, this looks like 3, and then how about like the ones in the middle here? Okay, they look like 8 and 9. And then I can even like use this chart.value, put it into a data frame, save it somewhere, or use it as a way to filter out my data set. So I hope this like sparks your creativity in how you work with data. Instead of it being a very static way of like top-down approach, you can actually go into the data and like visualize it and see what's wrong. Okay, so back to the original. I'm going to close this down. Okay, there's one more thing I want to show, which is, okay, first thing, we should add a markdown cell to say that this is a drawing graphs. I'm going to show you talk about SQL, but since I'm going to work in this notebook, let's clean it up a bit. One thing that I do want to say is because the DAG, like this graph, oh, it's using, okay, never mind. Forgive the, okay, so this DAG, since it's using, since the DAG is always like a directed graph, it doesn't matter how I order my cells. I can move these to the bottom, and I could put my charts at the top, and it will still work fine, right? The DAG doesn't change. So even if you share this notebook with someone else, it still works like you expect it to. Okay, so let's say there's this feature called SQL, and if you do want to write code that interacts with databases, you might want to use that. And so a cool feature in Marimo is you can change it to a columns mode. So instead of working top down, I can create a new column, and then I can create an SQL cell here, and let's just demonstrate. Yeah, it's using, oh, it just works out of the box. Okay, cool. So by default, we ship with DuckDB. So this is using an in-memory DuckDB. If you don't know what DuckDB is, it's an analytics engine that's really fast and powerful. So I could do this and like even read a CSV file. So let me just check one. I really like this demo, this CSV file. If you like Pokemon, this is pretty nice. So I'm gonna expand this. Oops. Let's expand it again. Okay. Is that good? Okay. So this is like a table in Marimo, and what it has is like all the columns. There's like summary statistics as well. And I can, let's say, go in and if I want to view more statistics of it, I can actually, okay, I can like inspect, like see the mean, the max, the median, and like do a very quick analysis of my data that I have in the notebook. So like these are the top 10 types of the Pokemon. So that's pretty cool. But you might be wondering, okay, how do I connect to a database? And we have this, on the left side here, there's something called Explore Data Sources. So if I click here, Add Database, and I click, so there's a bunch of databases which you can add. For this demo, I'm going to show MotherDuck. MotherDuck is a hosted version of database on the cloud. So let's add this. It's going to do it here. Let's move this here. So now I'm connecting to MotherDuck. Okay, it just works. Nice. So on the left, you can actually see like a schema of my database. So it actually shows you like Kaggle NYC, and I might want to go in here, maybe look at the taxi dataset, and maybe bring that into my notebook, visualize it, and now I can read from my database. And then I can maybe name this result to something like taxi. I can get that value, and then now I have a taxi data set. So I'm using Polars because I have Polars installed, and that lets me do something like text select, and maybe just choose this column. So very quickly you can see like, okay, I have this notebook. I use SQL to pull in my data. I can even make transformations here, like where, whatever. I can change it to Polars. I can even feed this back into DuckDB and read it as SQL again. So it's a very powerful workflow if you like using DuckDB and SQL and Python. So that's all pretty cool. And the other thing that's nice is, okay, this is using an older version. That's fine. Let's hope I have Gemini keys or not. Hello. Okay, maybe not. That's fine. I'm not going to show you that. But what you can do, if you're using AI and you're connected to a provider, you can actually reference the dataset. So I can say like, can you explain about taxi? And it would actually feed that context into the AI as well. Yeah. Okay, let's close this. I'm going to show you another demo. Oops. Yeah, I think something broke. Okay, strange. Okay. So the other thing I want to show you, let's hope the internet is fine. Okay, the image is not loading properly. Let's do Japanese, 20th century. Okay, so there's this API called Harvard Art Museum API. It's this one. And it just gives you a bunch of endpoints to query the Museum of Harvard. And what I did is, this is largely vibe coded, 80%, because the AI is really good at like dealing with Python files. Oh, I found it. Okay. So it can actually create this gallery for me. And sorry, the images are unloading. I think there's like poor internet or something. But what I can do is, if the widgets in Marimo doesn't satisfy me, I can use something called AnyWidgets. AnyWidgets is a way for you to create front-end elements And then you can attach like tradelets, which are ways to bridge the front end values to Python. So if I click on this element on the front end, like this is just JavaScript by the way, it actually triggers code in Python and I get back the value here. So it's receiving that front end value and then passing it back. I even have like a magnifying glass, but yeah, it's fine. So that's also pretty cool. And then I have a fine similar data set. So my idea was, could I plot all of these artworks on a chart and then see which artworks look this or like are clustered similarly. And there's like different algorithms for this. I think I'm using Clip, which is like a neural network trained to convert it to vector embeddings. And then what I can do is I actually visualize this on a chart, like all of these clip embeddings. And then I could even select some of them. Oh, yeah. Why are they all broken? Okay. And then I can go into that artwork and maybe say like, I want to inspect this. And then it actually shows me that, oh, these artworks, all of these points are similar to each other. And I use different algorithms to see whether it's truly matching. Like, for example, I chose this Thomas Copperwald Eakins image. And if you notice, this is the original one. So it uses different algorithms to compute whether those other artworks actually are close to it. And so maybe different algorithms would have different findings, right? Yeah. Anyways, wrapping up, if you want to try notebooks other than Python, Marimo is inspired by Pluto and Observable. So Pluto is for the Julia programming language, Observable is for JavaScript. They look something like this. Let me see. Yeah, they look something like this. And if you want to check out Marimo, you can try it, like install it locally as a Python package. You can also use Molab. Molab is like Google Colab but for Marimo. So we serve the compute for you. It also works in Wasm. And yeah, you can also connect with me if you want, if you have any questions. And that's all. Yeah, thank you so much.
All right, thank you so much, Shamir. And for anyone who has got, yes, we have one. Please approach the mic on the aisle.
Thank you for the report, for the speech. I'm interested about the example what you provided in the first slides, like x is equal 3,
Yeah.
is equal 4. And when we will change the value, yeah, we change the result. It's a very simple pipeline. Very simple pipeline. But I mean, well, not so many computations. But
Yeah.
it will work in generally in real time, in real life, we work with so much more difficult pipelines, what need compute, sometimes minutes, sometimes hours, if we will learn how we will manage that.
Yeah, great question. We get asked this a lot. So there's two things. One, if you go to the bottom here, there's this setting called on-cell change auto run. So if you don't want it to be like immediately reactive, you can change this to lazy. And what that happens is, like if I do x is 1 here, y is 2, let's do x plus y. Let me zoom in a bit. And if I make this x is 5, I run this, it doesn't immediately run, but it just marks the cells that need to be run as stale. So that's one way to achieve this.
And second question is to say that Python notebook, this is JSON.
Yeah.
What executed the part of the JSON executed on the server or okay. What is it? What's different structure, inner structure of IPython notebook and this notebook?
IPython notebook or Jupyter?
Yes, you said IPython notebook, IPy and B.
IPY and B. Yeah.
This JSON, what is it? What's the difference? It's also JSON.
It's not JSON.
Yeah. It means it's created for code. Okay.
Yeah, just Python. But maybe a note would be like, so the outputs aren't stored in here. Anyway, we can talk about it later as well. But yeah, it's just Python. Yeah.
I'll just project my question.
Yeah, sure.
Is there a way to easily convert IPython notebooks already to Marimo?
Yeah, there is a way. There's a CLI way. Let me quickly show you. Migrate from Jupyter, yeah. There's like some CLI tools you can use, and it will like recognize, for example, there's magic commands in Jupyter, and it will convert them automatically to like dependencies or other stuff. Yeah.
And then just one more follow-up question. Do you have like plugins, ecosystem? For example, you want to incorporate Vim hotkeys in your cells. Do you
Yeah.
already have that already?
We do. We have some. So it's open source. There's some contributors who use Vim, and there's like Vim plugins. There's also a VS Code extension if you want to use this in VS Code. Yeah. Shout out to Trevor who built that. Yeah.